recharge. The tritium, it's an indicator of recent recharge. As you can see in this figure, the correlation between tritium and oxygen 18. For the tritium with a high amount, more than 1 unit, we have a recent recharge, and for the sample where we have low content of tritium and very depleted value in oxygen 18, they represent the old water. In Wedlaya coastal aquifer, the distribution map of the carbon-14 show that in this coastal zone, the recent and renewable water are located near the coast, while the old content of the carbon-14 and the old age are located in the deep aquifer located in the southwest part of this aquifer. The carbon-14 also allow to give an idea about the age of water, and for the continental intercalaire, we have very old water, as you can see in this content in percent of modern carbon. The tritium and also the carbon-14 can be used in the modeling of renewal rate and the estimation of the recharge rate. For this purpose, we use a conceptual schema of model for the estimate of the renewal rate. It's a simple model of vertical mixing. The model assumes a uniform isotopic phases through the thickness of the aquifer. For El Hawariya, we have about 30 meters of the thickness of the aquifer and a constant water storage. That means that we have the discharge of the water. It's exactly compensated by the recharge to estimate this renewal rate. And also we can use this model with the variation of the reservoir. I mean, if we have an increase in the piezometry or a decrease in the piezometry. For the El Hawariya aquifer, since 1980, we use this model with this equation without decrease in the piezometry. And for this model, we have to have the activity of tritium or the activity of carbon-14 in the water sample, also in the rainwater. For tritium, if we have carbon-14, it will be in the atmosphere, and we have to know the period of the radio isotope and the activity. For the decrease of the piezometry, the equation of this model will change to this equation. To run this model, we have also to estimate to have the result of the composition of tritium and tritium in rainwater and carbon-14 in the atmospheric water. For rainwater, we have the Tunis-Carthage rain station. We have measurement since 1968, and for the samples before this date, we reconstructed this value by extrapolated neighbors station like the rain station of Alexandria in Egypt, or Algiers in Algeria, and some other rain station in south of France. The result of the model give about for 2008 with a median value of tritium in the aquifer, we have 0.2% of renewal rate, and for 1980 we have 0.3% of renewal rate. With this value of renewal rate, we can estimate the recharge rate through this equation with the thickness of the aquifer and the porosity, and we can estimate the recharge rate for El Hawariya with the thickness of 90 meter and porosity of 14%. We have a recharge rate about 12 millimeter per year, and for the Oriental Coastal Aquifer, for a total thickness of 43 meter, we have a porosity of 12%. We have a recharge rate of about 10 millimeter per year. These values are very close to the recharge rate in the semi-arid area in this region. And the salinity, as a conclusion, we can determine this origin of the salinity with hydrochemical and isotopic data, with combination of the hydrogeologic information. We can have an idea about the origin of the salinization, dissolution of salt, alite, and gypsum within the recharge and water interaction and cation exchange. Also the irrigation return flow and in some cases sea spray. Since we are in the semi-arid area, a coastal zone, and prevailing wind in the Mediterranean Sea, the evaporation of water can contribute to the increase of the salinity, especially close to the Setra or salty lakes. And the seawater intrusion was estimated between 1 to 70% in the Oriental Coastal Aquifer and less than 1% in the Al-Hawariya Aquifer, with these tools like the piezometry drop, the salinity map, and the geochemical ratio, and the stable isotope of the water molecule. And thank you for your attention.
Any questions?
You mentioned using fluoride to bromide ratios for detection of saltwater intrusion. Have you also looked at like land use and like wastewater inputs in conjunction with those kind of ratios?
For the estimation of the salinity coming from the wastewater, the better tracer is the boron. Yeah, the boron, we can estimate, we can make this relationship between boron and chloride, and also the isotope of boron, boron 11, with oxygen 18 or with chloride 73. There is many good tools for the estimation of the salinity of groundwater. Among these tools, we can cite the sulfur 34. We can correlate the sulfur 44 with the sulfur 34 in the sulfate. Also the bromide 87 with the chloride 37. The oxygen 18 deuterium, and also the chemical ratio, and the best tracer for the chemical are bromide chloride, sodium chloride, and also calcium chloride and calcium magnesium. With these four graphic, we can have a big idea about the origin of the salinization from these chemical tools.
Thanks.
Yeah, along the coast, I see a huge variability or gradient of salinity. If the main cause is Southeast region, why they have this gradient of salinity along the coast?
Why we have a big difference between place to place? Because the geology of the region. For example, in the Oriental Coastal Aquifer, in the 60s, there is no seawater intrusion. The aquifer was, the water was very fresh. And after that time, the water authority has made modification in the direction flow of they broke the littoral barrier composed by the Tyrrhenian, and they favorite this seawater intrusion. And you know, from place to place, it's very different. In some place there is no, but the biggest place is located close to two rivers reaching the coast, and in this place we have a big seawater intrusion, and this seawater intrusion was intensified by the over-exploitation in this area, because this area it's a rural area, and they use the irrigation for irrigate the tomatoes, and they use a big amount of water for irrigation, and they favorizate this seawater intrusion through the over-exploitation of the aquifer. And the mainly reason of this difference between salinity from place to place, it's caused by the geology of the region.
Are you, for management and planning purposes, are you or your colleagues thinking about sea level rise? Are you doing any predictions based on your data now? How it's going to be?
In my case, I would like to work on this problem of seawater rise, but I don't have the possibility to work to this field. But I know that in some place, especially in this place in Sousse, located in the east part of the country, it's very touristic. When I was young, the beach was very large, and it's about 40 meters, 40 to 50 meters. Actually, this beach, it's about 7 or 8 meters, and it's due to this raise of the water level and the bad exploitation of the seashore. Yeah, I think it's international, this problem of seawater rising, and maybe, I don't know, here if in Hawaii you have this big problem actually, or
Looks like we are getting it there.
okay.
There is some concern that we have like maybe up to 1 meter rise in many years to come. So we have to be very careful.
In Morocco area, they have very accelerated places, and the cities where, and the houses located very close to the sea. Now many of these houses are abandoned, and because of this rising of the seawater level.
Do you know, do they see more seawater intrusion due to that, or too soon to tell? Seawater intrusion.
Where?
Because of sea level rise.
Yeah, the seawater intrusion, it's the seawater rise, it's one of the, but it's not the principal aspect. The principal aspect is the over-exploitation of the aquifer. You know, the farmer in my country want to have a big yield of production, and they over-exploit the soil. They use maybe 3 to 4 type of culture per year, and they don't use an economic irrigation techniques. So in some cases they use surface irrigation, and there is a big amount of evaporation. So they have to extract water, and if they have a drop of the bathymetry, they drill a new well, and they increase of this problem of and many of these lands now are abandoned, and the soil of this region has a big amount of salt, and they can't cultivate it even for the halophyte species.
Any other questions? Okay, so how about other sort of contamination because of agriculture? Do they overuse fertilizers?
Yeah.
Pesticides?
Yeah, we have in some places, especially in Hawariya Plain, very huge problem of the contamination by nitrates, because in the region of Gabon, so this region is famous by the orange production, and they want to have big size of the orange, so they put a lot of amount of nitrate for fertilizing these orange trees, and in some wells we reach 600 milligram of nitrate per liter. 600 milligram of nitrate per liter. Yeah, it's very. You know the amount of for drinking water for nitrate. It's between 20 and 40 milligram per liter. This is the standard of the World Organization, Health World Organization. It's 20, and in my country the maximum admissible it's 40 milligram per liter. But in some places, the farmers use the water for irrigation, but also they use the water for drinking water from the wells. And they know that they have a big risk on the human health, and in some cases they said that they don't have choice. They have only this source of drinking water, because not all the cities are connected with the drinking water network, only the cities, but in the rural region, I think it's the same case in the United States. The farmers have their own wells, and they use it for drinking water and for irrigation.
Actually, here it is recommended even to be less than 10 milligram per liter.
Here,
So especially babies can get
yeah,
disease.
because the disease of blue heart
syndrome.
syndrome.
Okay, how about management? Is the government doing something about
Yeah,
it?
in the eastern coastal aquifer, they put forbidden area, and in many places they put also a safe area. For the forbidden area, nobody has the possibility to drill a new well, and you know, in some places they drill, the water authority drill a well or a series of wells close to the seashore to pump the salt water and transfer this salt water to the sea. It's a new technique to protect. That means if we have here wells, for example, in this place we have wells, the water authority can implement a series of wells here, and they drill and they transfer this salt plate, this salt water to the sea. Yeah, because the flow rate comes from the upstream to downstream, and when this water level of salt water will decrease, the fresh water will push the salt water. Yeah.
Okay, all right. Thank you, Dr. Hamouda. Thank you.